Now that we've explored some of the basic operators defined in RxJava's single class, it's time to see how those operators can be applied in the context of case study ex1. This case study examines the use of the single just, fromCallable, map, doOnSuccess, and ignoreElement operators. You can find the source code for this case study in the link at the bottom of this slide. We're now in the IntelliJ project for RxJava's. We're now in the IntelliJ project for case study ex1 in our RxJava single class example. We're now in the IntelliJ project for case study ex1, which demonstrates some of the operators defined in RxJava's single class. Let's first take a look at the ex1 class itself. This class provides the main entry point into the test program. As you can see, it goes ahead and registers two method references with async task barrier. The first method reference that's registered is called test fraction reduction sync, and this tests a synchronous big fraction reduction using a single and a pipeline of operations that run on the calling thread. They don't use asynchrony, in other words. And test fraction reduction sync 2 is registered with the async task barrier. It also tests synchronous big fraction reduction using a single and a pipeline of operations that run in the calling thread using slightly different operators and slightly different helper methods, just to make the example slightly different. Both those methods are registered. We then use the async task barrier run all tasks method to run those tasks. They actually run synchronously, but that's okay. In this case, we run the tasks and then we use the blocking get operator in order to block the calling thread until all the methods that are registered are done. And then we print out how many tests completed successfully. Let's now go ahead and take a look at single EX. This is where all the fun happens. The first thing we'll do is take a look at a field that's defined here called S unreduced fraction, which is just going to be a big unreduced fraction that has some large numerator and denominator values. So you can see that's a big fraction that's unreduced. And we're going to use that in both of the methods we're going to look at in just a moment. The first method we're going to look at is called test fraction reduction sync 1. As you can see here, it uses a string builder in order to allow us to append the various diagnostic information we want to print out later and then display it in one fell swoop using the string builder mechanism. We can use string builder in this context because this particular method runs synchronously in the calling thread, and so there's no need to worry about thread safety. If we had used background threads, we'd have to use string builder instead of string buffer. So let's take a look at the pipeline of operations we use off of the single class in RxJava. We start by using the just factor method operator to begin synchronously reducing the big fraction in the calling thread. So we pass S unreduced fraction in to the reduce method, which is a factor method of big fraction, and that returns a single to a big fraction. We then use the doOnSuccess action operator to print the big fraction. Of course, if something were to go wrong, doOnSuccess would be skipped. Fortunately, nothing is going to go wrong here, but if it did go wrong, we wouldn't print anything out. And you can see what happens here is that since doOnSuccess is an action operator, we don't actually modify the value that's passed in, the big fraction, but instead what we do is we go ahead and append some diagnostic information indicating what the unreduced fraction was and the reduced improper fraction and so on and so forth, just so we can see what happens when we run the program, which we'll do shortly. The next thing we're going to do is we're going to use the map transforming operator to call a function that converts the reduced fraction into a mixed fraction as a string. And that function, of course, is the big fraction to mixed string method, and that will go ahead and make the conversion. So now we end up with a single to a string. Remember, map can change the type and the values of the input it gets, and it actually does that in this case. It returns a string instead of a big fraction, which is what it got as the input. We then go ahead and use doOnSuccess. Once again, we use this action operator to print the results of the mixed fraction reduction. And then the last thing we do here is we display the string builder by converting it to a string and printing it out so you can see what the results are. The last call, the last operator that's used in this single chain is ignoreElement. And that returns a completable that's used by the async task barrier framework to indicate that this computation is finished. Now, once again, this is all running synchronously, so this is a bit overkill, but it's helpful to keep things consistent in order for the async task barrier to work transparently for both synchronous and asynchronous computations. Let's now go ahead and take a look at test fraction reduction sync 2, which is very similar to test fraction reduction sync 1 with just a couple minor differences. The first minor difference is that instead of using single just as our factory method operator, instead we're going to use single fromCallable. So single fromCallable is just a little bit lazier. In this particular example, it doesn't make any difference. In other examples, it could make a difference. But in this case, we're simply going to create a single that will reduce the S unreduced fraction field that we looked at the very top of this particular class. The next thing we're going to do, much like we did before, is we're going to call the doOnSuccess action operator and take the BigFraction and log it. This time, rather than writing all that code in line, however, we're going to have a helper method called log BigFraction, which will just use the string builder that's passed in to append the diagnostic information to the string builder. So it's just a little bit cleaner. The map operation is identical to before. It converts the reduced BigFraction into a mixed BigFraction string, converting both the value and the type. We then use doOnSuccess again, and this time we're going to display the mixed BigFraction, and you can see what this does is it just goes ahead and appends some diagnostic information and then converts the string builder to a string and then displays that string. You can see if we go take a look at what display does, it's going to print out the thread ID where the call was made, which should be the main thread in this case because everything's running in the calling thread, and then it prints out the string. The last thing at the end of this method is ignoreElement, and once again, that returns a completable that's used to synchronize with the async task barrier framework. What we're now going to do is we're going to go ahead and run the program so you can see what the output's going to be. We click on the little run icon, and you can see that the results demonstrate that the output is all produced in the calling thread, which is the main thread, thread ID 1. And as you can see here, we get the unreduced BigFraction, then we get the reduced improper fraction, and then we go ahead and print the results of the mixed reduced fraction. And in both cases, the inputs were the same, so naturally the outputs are the same. The only difference being that test fraction reduction sync 1 uses single just to kick things off, whereas test fraction reduction sync 2 uses single fromCallable to kick things off. As I mentioned before, there can be contexts in which those will differ in their behavior, but in this context, they give the same results. And so, of course, we get the same outputs.